Welcome back. In this video, we'll show you how to build a flexible do-it-yourself file server on Ubuntu Linux that mimics Unraid's best features, disk pooling, redundancy, and a web-based GUI using entirely free open source tools. Now, if you've seen my previous videos on Unraid, you know my thoughts on it. I think it has a lot of great features, especially the use of mixed-size drives, but the price at $200 is arguably a bit steep for some. And the idea is here to show you how you can build similar functionality doing it entirely for free. Now, it's not going to be a perfect replica of Unraid, and Unraid still will have some features which are a little better, and it's not going to be as easy. Maybe this is a path you want to pursue if you don't want to go down the path of paying for Unraid. So our goal is to combine mergerfs, which we'll use for pooling drives, snapraid for parity-based protection, and then Cockpit for web-based administration into one solution that gives you Unraid-like functionality without the license. Now, Unraid is known for letting you mix drives of different sizes in one big storage pool with single or dual parity for protection, all managed through an easy web interface. We'll recreate that step by step in the following way. So first, we'll use mergerfs to pull multiple disks into one large virtual drive. No striping, no complex RAID, just a unified storage mount. We'll use snapraid to add parity information for redundancy, protecting against disk failures and even detecting bit rot if your data is mostly static. And then Cockpit will provide a friendly web-based GUI for monitoring and managing your file server, which is similar to Unraid's web-based dashboard. Now, one other thing I want to mention before we jump in is you'll commonly see this solution discussed as a way to host a home media server where you have large amounts of file storage that doesn't change very often, because the tools we're about to look at actually work very well in that use case where you can bring mixed drives together. You don't have on the fly RAID and you don't have data changing very much. But I found like this is also a good solution for, I think, many people's just file storage needs. I'd be willing to bet in a lot of home cases, you don't have tons of data changing a lot. You probably have mixed drives all over the place. And the one thing I found was missing was the web-based UI. So I'm going to take a slightly different spin on this and present these tools as something to build your file server on, not your media center. But you'll quickly see when I do this that you could throw Plex on it or another media center and pretty much be in the same place. All right, now let's get started with drive pooling using mergerfs. So to start, we need to pool our disks into a single storage volume. Mergerfs is a union file system that merges directories from multiple drives into one unified mount point. In other words, if you say have 3 drives mounted at different locations, say /mount disk 1, disk 2, or disk 3, mergerfs can present them all as one combined folder, again in a separate mount point on your file system. Similar to how JBOD spanning works, but unlike RAID, each drive remains independent with its own file system, no striping or mirroring. You can add or remove drives easily with no data rebuilding, mix different drive sizes without wasting space, and if needed, you can read any drive's files on a normal PC since they're just a standard file system. It is whatever file system you choose per drive, ext4, XFS, etc. So why would you use mergerfs? Basically because it's simple and powerful. Mergerfs basically takes a bunch of drives and turns them into one big drive from the user's perspective. Unlike conventional RAID, it doesn't offer redundancy by itself. It's purely for pooling. But that's okay because we'll handle redundancy with snapraid in the next part. The key benefits of mergerfs include no special hardware needed. Drives can be added one by one as you add more space. There's no lengthy rebuild process when adding or removing a drive, and this makes it perfect for certain file storage applications like media storage, as I mentioned above, but probably most people's file storage needs. And you can also upgrade disks as you're going. So under the hood, mergerfs is a user space file system. It doesn't actually move your data or combine bits at a low level. It simply joins directory trees. For example, if each disk has a movies folder, mergerfs will show one big movies folder containing files from all the disks. When you create a new file, mergerfs decides which disk to place it on using a policy, which you can choose when you set up the file system. So for example, you could choose policies such as most free space to fill the disk with the most free space first, or existing path to keep a folder's files on the same disk if that folder already exists, etc. And so it's important to understand these policies when you set up the file system because it will affect how your storage works as you start to scale it up. Another thing to consider is, and I mentioned this with Unraid, remember Unraid works a similar way. You start to fill up the drives and it moves like the data to the next free drive, etc. And so you're basically IO limited by a single drive. And that is the case with mergerfs as well. You're not going to get the IO striping you get with RAID and all the good stuff there. So again, this is probably best for home lab use cases where you're not doing tons of IO on the drives. So why don't we take a look at how to install and configure mergerfs on Ubuntu. So I have a machine, actually a virtual machine here in front of us. And actually, let me pull up a web interface and I'm running it on Proxmox. So let me pull up a view and show you something. So here you can see my Proxmox interface and I have the merger, I spelled it wrong, FS VM over here. And let me just show you the hardware section. So you can see, just for demonstration purposes, I set up a whole bunch of drives on this of different sizes. So we can combine these together using mergerfs into one volume from user perspective. And this first disk is actually the OS itself. All these small ones starting with 15 gigs up to 32 are the drives we will use for this test. So here we are on the machine, and installing mergerfs is as simple as using Ubuntu's apt command. All right, and you can see I already have it installed, so easy enough. So let me just show you all the drives I have set up on this machine so you can see how we'll bring them together using mergerfs. So I'll just start by showing you the drives themselves so you can see, similar to what we saw in the Proxmox menu, we have the 15 through the 32 gigabyte drives, and I have them mounted in very obviously named locations for this demonstration. So you can see also on DF, there you go. In mount drive 1 through drive 6, I have those ready to go. And so what I'm going to do is I'm going to use mergerfs to bring them together into the all storage directory. And here's how you do that on the command line. All right, it's that simple. And so you can see this command is pretty obvious, that we just listed all the drives we want to bring together here, and then the location here, and then a number of additional parameters. And the key thing to pay attention to here is the policy you want to use. And if you want to learn more about all the policies, you can simply look at the man page. In this case, MFS is most free space, but I'll just show you real quick. Here are all the policy descriptions that you can use with mergerfs. So you can see, I'll just go down. Here we go. MFS, most free space. EP MFS, I think, is probably the standard now. And this picks the drive with the most available free space. So that seems reasonable for most cases. But it's probably worth reading through this before you set yours up to make sure you get the policy you want. Now, just to show you how this works, what I'm going to do is I'll just go create a file or a folder in one of these drives, right? These are all mounted, but we'll see it come together under all storage. So we'll do this. All right, so made a file there, which you can see. But then also if we look under all storage, there it is. You can see the same file because you're getting that view completely brought together. And now what I can do is I can do the same thing, but I'll do it on another drive just to show you how they come together. So I'll do drive 4 and we will put foo2 over there. And then if I look in all storage again, there you go. You can see the two files next to each other. Same would be goes for directories, right? So I could do, so let's put this on drive 5 and we'll just call it, like, imagine you were storing some data over here and we'll call this docs, right? And now if I look at all storage, there is that docs folder. So pretty neat. And just for fun, using the magic of ChatGPT, I had it write this script, which will create a bunch of temp files that we can populate these directories with. Again, just to show you how mergerfs works. And what this does is it'll just go create 5,000 files in a directory, and those files will be of varying size. So let me just show you. I ran this offline for a second. And what I did is I ran it one time with drive 1, each of these directories as a parameter. So drive 1, 2, 3, 4, 5, 6. I created 5,000 files in each, and you can see that. If I say look at drive 5, you got a whole bunch of files there, right? And we can see 5,002. And then if I look at all storage, you can watch the view bring all these together. And there you go, a little over 30,000 files, which is what we would expect. So now that we have pooled storage, let's add some protection to our data. So snapraid will give us parity-based redundancy, similar to Unraid's single parity disk system. So snapraid is an open source snapshot RAID solution. It computes parity information for your data disks so that if one, or possibly multiple, depends on how you configure it, drives fail, you can recover their contents using parity data. The key is it is not real-time RAID or not real-time parity. So instead, like on Unraid, the parity is calculated in real time. With snapraid, you run a sync operation periodically, like a cron job, which you would run nightly or weekly, I guess, if you have a risk tolerance. And what that does is that updates your parity snapshots. What this means is snapraid is excellent for data that doesn't change very often, but it doesn't work well for fast changing files for obvious reasons. You're only taking a parity snapshot as often as you configure it. So that is your window of risk if you were to lose a drive, right? So if you were, say, storing VM disk files or something else on here, using snapraid may not be your best idea, but it's up to you. So with mergerfs and snapraid, you have Unraid-like functionality. mergerfs gives the unified storage pool, and snapraid gives the parity protection, somewhat like Unraid's parity drive. The big difference, Unraid updates parity on the fly, which can slow down writes, whereas snapraid updates parity when you tell it to, and assuming you'll schedule it. So if drive fails, you can recover everything as of the last time you ran snapraid sync. If you haven't synced recently, you might lose most of the recent changes on the failed disks. So make sure if you're going to use snapraid to run your syncs regularly and make it automated. So let's show you how to set that up right now. So installing snapraid is as easy as installing mergerfs was. We'll just use apt. So now that snapraid is installed, we're going to need to set up a snapraid.conf file to configure it. And so I will open mine up. I think I may have some configuration in there from a previous try at this, but we'll walk through it and I'll show you exactly what you need to configure. Okay, so let's walk through this. So the first thing you need in the configuration file is shown at this top line, and you need to tell it first where the parity is stored. And so this is your parity disk, right? Here you are providing a path to a parity file, but remember, for redundancy purposes, you want this to be a separate disk, and it should be at least as large as the largest disk in your collection. And so what I've said here is I'm going to store my parity on /mnt parity, and then snapraid.parity is the name of the file. Now, if you're paying close attention, I actually, in this case, I didn't set a separate disk up for parity. Just for this demonstration, I'm actually using my primary OS disk in this case. Not ideal, but it'll work, and it is a separate drive. But you would ideally want to have an actual separate drive for that. Now, the next section that begins with these content settings here. Now, this tells snapraid where it is going to store its index files. And you're going to want to put one of these on each of the drives in your mergerfs pool. And so you can see here, I had already listed a bunch of them out corresponding to those directories that I showed you previously. So I have an index file on drive 1, 2, 3, 4, 5, and I will need to add one in for drive 6 as well. And then lastly, in this section, you'll need to define the actual data disks. And you can see I have a problem right here. And you just kind of label the disks. Disk 1 through disk 5, you can label it however you want, but then you actually need the path to the mount point of that drive. And I will need to amend this to update with drive 6 as well. Now this, you remember, you are dealing with your underlying drives. Notice in all this configuration, we didn't talk about the mergerfs combined mount at all. The RAID is operating at a per drive level, and then mergerfs is bringing all that together into one view for you. But when you're setting up the snapraid, you want to do this you're setting it up for each of the drives in your configuration, because what you want to do is you're providing parity across those drives and redundancy in case one of them fails. So let me just quickly make the updates to this to add the one additional drive. Now that is it. That is a simple snapraid configuration file. There's actually more configuration you can add to this, including files to exclude, etc. So if you want to save storage on parity or configure it slightly differently, you can dive into all that in the snapraid configuration, but that should get us started for now. So we have our snapraid configuration ready to go. Now we're ready to use it. There's really nothing else to do. So the first thing we want to do is run our initial sync. And this is the process that goes through and builds the initial parity set, the parity file, as I said. And this is the operation that you would want to schedule on a regular basis. But what we're going to do is we'll just run it on the command line so you can see what happens. All right, so this is off and running. Looks like it might take a minute, so we'll just let this do its thing, and then we'll come back. All right, snapraid is all done. So now you can run other commands like snapraid status if you want to see what's going on with it, and it'll take a look and tell you all about your file system. And while we're at it, I'll show you a couple other fun commands. I'll show you snapraid diff. And so this will let you know if anything has changed since the last snapshot you took. And again, you should be running on a periodic basis, but you can see no differences, which makes sense. So let's actually change that and see what happens. So I'm going to quickly add a couple files. All right, so I just added 2 files, and now let's run diff again and see what it says. All right, it says there are differences. So you can see that there was an add on the 2 files, the bar and bar 2 I added. Not surprisingly, now if we wanted to kind of catch that back up, we could just run sync again. And there you go. What's interesting is I don't know why it says nothing to do, but it obviously did something because it says we ran diff again and there were no differences. And then finally, remember, you can also run a scrub command that will verify the parity and check for bit rot. So again, this is something else when you're setting up your cron jobs to run this. You might want to run this periodically as well, just to check. All right, for one more exercise, let me show you how to recover from data loss. And so let's just go into say drive 3. I'm going to remove everything in here except for the snapraid content for now. I'm really just going to remove the files to show you how you could actually go recover lost files in the case that maybe you accidentally deleted something. All right, so that's gone. And just to show you, so that should be about 5,000 files left. So there you go, about 25,000 files. So we just lost a whole bunch of files, but those are stored in the parity. So let's just run a diff and see what happens. Oh, interesting. So it tells you right here, it knows the names of the files that were removed, and it knows 5,000 were removed. So what we can do is we can just run fix. And there you go. It's going to go through the process of recovering the data for each of those files using the parity file. So we'll let that run and see what happens when it's finished. All right, it finished recovering the files. So let's take a look. Now we had deleted everything in drive 3. So let's see what's in there. All right, and let's take a look at how many files are in there. 5,003 sounds about right. And then let's look at the view that we get through mergerfs. And 30,008 files again, which is right. So there you go. Quick example of how snapraid can provide some level of redundancy similar to Unraid. And I just want to iterate again, parity is not real time. You need to run those sync operations, but we just saw how those sync operations work and even how to recover from data loss, which we just simulated right here by nuking a bunch of files. All right, so the final piece of this build is to use cockpit, which is a web-based GUI for administering Linux servers. So think of it as a lightweight control panel for your Ubuntu server. Once Cockpit is installed and running, you can log into your server from any web browser to monitor hardware, manage software updates, view logs, start and stop services, and even administer storage, containers, and virtual machines, all through like a nice interface. And you can access the file system directly too. So you have like a way to upload and download files right through a web browser. Cockpit will emulate the convenience of Unraid's web dashboard and allow you to manage everything on your server and without needing to SSH in for every little thing. Now, I did an entire separate video on Cockpit that will go a little bit deeper than we will go here. But once again, this is provided out of the box with APT, so you just go ahead and install it. And you can see I had that installed, but again, it's really that simple. So now I'm just going to show you. I'll bring a browser over here, and all you do after you install it is go to port 9090 on your host, and you can just log in with your account. It just uses the accounts you have set up on the machine. So nothing really special there. All right, and here we are. Now I want to remind you that Cockpit does have a number of plugins that you need to install using, most of them are available again using APT. but you'll want to go through and make sure you get all the plugins you want. So over here on the side, you get all the kind of capabilities you want, such like virtual machine management does not come out of the box, I believe. And then for some of the other plugins, I think for the file system management, you actually may need to go grab that yourself and install it. However, this is just to kind of show you what Cockpit offers and how it is somewhat similar to what you get with the Unraid web UI. So you can see the health of your machine. You can look at metrics and history on your CPU and drives and utilization. So here, this is actually neat. So you can see all of the drives on your machine and how much is free on them. You can dive into the hardware details on the machine, similar to that Unraid UI. I would say in this case, probably not as concise as it is, but hey, it's free. You can look at logs, dive into storage. Now you can see I'm not, oh, I am. I was going to say you can manage containers through this UI. Or the other thing you can do if you were big into containers is you could just install Portainer on the host and run it that way. And of course, you can do virtual machine management, which I can't show you now because it's disabled on this VM. But you can do it right from here, all very similar to that Unraid UI. So I encourage you to go spend some time digging into Cockpit or check out my other video on it to see like how you configure it a little bit more for your particular use case. Oh, and it is worth pointing out, you can always go right to a terminal here. So we can go to our terminal. And there we go. We can actually see all the stuff we just did. We can see our 6 drives, and then we can see our mergerfs file system right there. So let's wrap this up with a couple easy steps. I mean, this was all just included out of the box and a little bit of configuration. We have kind of a do-it-yourself Unraid-like NAS solution. So just to kind of recap what we did, first we installed mergerfs and merged multiple disks, varying size disks, by the way, into one volume. We configured snapraid and added a parity disk and synced parity, giving us protection against disk failures and corruption. And finally, we set up Cockpit for easy web management of the file server. With this, your server is pretty much ready to go. A little bit more work than setting up Unraid, but like I said, it's free and it works really well. One thing we didn't cover was, and since we're sitting in front of Cockpit, it's worth mentioning, obviously you'll want to go through and set up shares. I think you can do it right here in the UI if you want sharing via SMB, sorry, or NFS, you can do all that right here. And then you truly have a nice file server at your disposal with out-of-the-box Linux software. So it's great. So with that, we'll leave it here. If you have any questions, or I'm curious how you have approached building a system like this where you wanted Unraid-like functionality and mixed size drives and redundancy support, etc., let me know what you think down in the comments, and we'll see you next time.